In the Berkey Academy, I already have a series of videos that I call Econometrics 6, Statistical Inference. And in that series of videos, I purposefully spent a lot of time developing the intuition and the logic and the overall idea behind hypothesis testing, and never went into the nitty-gritty details of how do you actually calculate a particular kind of hypothesis test and look it up on the tables. And so that's what this short series of videos is going to be. I'm going to do a quick either introduction or review of hypothesis testing so that you can quickly get an idea of what's going on. But I'm going to spend much more time on actually how to do it. I recommend that you also spend some time with my Econometrics 6 Statistical Inference series of lectures because there is a lot of valuable information there as well. It just depends on what your purpose is. Before we get going though, we need to spend a few minutes reviewing some very important concepts from basic statistics. And the first concept that we're going to see over and over in all kinds of statistics, but especially when you're doing statistical inference, is the idea of a deviation. And a deviation is simply to take some number, call it x, and to see how far that number is from the average. And so a deviation you can just think about as x minus the mean, or x minus the average of some numbers. Very simply, an example we're going to look at a lot is using IQ because the numbers aren't very complicated. The average IQ of people in the population is 100. So if the average IQ is 100, suppose someone walks in and they have an IQ of 90. That would mean x is the 90. The deviation is simply 90 minus 100 equals minus 10. That's our deviation. It's nothing complicated, but it's just a word and it's an idea that we're going to return to time and time again. So a deviation is how far is a number from average. How far is some number from the average? Very simply. Now a standard deviation, there are a lot of definitions for the word standard that you can find in the dictionary. The definition, the idea of standard that we want to use is common. Standard means common. And a common or standard deviation is just a common distance that numbers are from the average. So a common distance, numbers in a data set are from average. So just think about standard deviation, common deviation. Now what do we really mean by common? Well, again, let's think about IQ. If we had 100 people in a room and the average IQ of those people in the room was 100, then what's the common distance of the people in the room? How far are they from the average? Kind of what's a common distance? Not the smartest person or the person with the lowest IQ, but common. How far are most people from the average? And so, to give you a concrete number to think about, for IQ, the standard deviation, I'll abbreviate that SD, although sometimes we use the letter S or the Greek letter lowercase sigma. The standard deviation for IQ is 15 IQ points. So a standard deviation says if the average is 100, then most people in the room will be somewhere within 15 points of the average. That's a common deviation, a common distance people are from average. So if you make this range, which we'll do in just a minute, of 85, that's a deviation below average, 100 minus 15, and 100 plus 15, 115, that most people will be in that range. So that's the idea of a standard deviation. And we're not going to worry about how that's calculated. That's topic for a basic statistics class. Now, to get a little bit more, even more specific with this idea of a deviation and a standard deviation, we have something called the empirical rule. Empirical means what we see when we look at data. And what we usually see when we look at data, not all the time, but a lot of times we'll see that the data we collect falls into a bell-shaped symmetrical distribution. And a bell-shaped symmetric distribution, the most common one, we call the normal distribution. And if you have data that has a bell-shaped symmetric distribution, and you know what the mean is, and you know what a standard deviation is for that data, then this empirical rule tells you a lot about that data. It tells you that 68%, most of the data, right? 68.26% is going to be within one standard deviation of average. What's within one standard deviation? Well, it's between 85 and 115, as we said before, for IQ, because the average is 100 and a common or standard deviation is 15. If we go out to 2 standard deviations above and 2 standard deviations below, we start at 100 and we go up 15 and another 15. And we go down 15 and go down another 15 to make a range. Then we're down to 70 to 130. What's true about an IQ of 70 and 130? Well, 95%, a little bit more than that, 95.44% of people are within 2 standard deviations of average. And it's not just IQ, it's also height, birth lengths, anything that has a symmetric bell-shaped distribution like a normal distribution. Now, if you go out 3 standard deviations, you get almost everything, and almost all your data. 99.73% of your data. So that's going to be almost all of your data, almost every one. What's 3 standard deviations in our example? Well, that would be 55 up to 145. The reason we talk about the empirical rule is to give you something to remember. I recommend memorizing these numbers: 68, 95%, 99.73%. Because we're going to be using this idea of a bell-shaped distribution quite a bit. And if you know these numbers, it will make more sense when we calculate them later. And the last idea we have to review quickly before we get started with hypothesis testing is the idea of a Z-score. Now, a Z-score, let me write the formula down. It is take some number, x, subtract the mean. Well, that's a deviation. We see this idea of the deviation again, a number minus the average. But then to get a Z-score, we take that and we divide it by the standard deviation. So that's a Z-score. So usually we would say Z is equal to a deviation on the top divided by a standard or common size deviation on the bottom. Let's use an example. Suppose my IQ was 130. That's x. So a Z-score for me would be 130 minus the average, which is 100, divided by a standard deviation, 15. What do we get? 30 over 15, which is going to be equal to positive 2. Well, we knew that already, right? We just had a formula that calculated something we already knew, that if I'm 30 points above average, 130, that is 2 standard deviations above average. We saw it right here. A Z-score just answers the question, how many standard deviations away from average is something? How many standard deviations away from average? And the positive sign just tells me that I'm above average instead of below average. A negative deviation, like we had here with the 90, means that the 90 is below 100. It's below average. And so a z-score answers the question, how many standard deviations away from average is a particular number? So that makes 10 minutes for this first getting started video. I'm going to end here and start with a second video where we dive into the logic of hypothesis testing, and then shortly after, I promise, we'll get into the actual mechanics of doing one.